Welcome to Week 10, Access Control and the Enterprise System. Access controls and authentication within the enterprise is a large-scale problem with multiple solutions. Each enterprise has its own way of handling it, depending on the risk associated with the information and how important it is. The higher the risk of attack, the more response that the organization must have. So our objective today is design an appropriate authentication solution throughout the information technology. Infrastructures based on user type, data, and classifications. So we're going to be looking at access control lists, the ACL, access control entries, which access control models are best and commonly used, what authentication factors should we have, how a 2- and 3-layer access control protects the network. We're going to look at the IEEE 802.11 standard, wide area networks, and some of the best practices for private and public. That's what we're going to be looking at today. So, what is ACL? We covered this a couple of weeks ago in Chapter 8, I believe. Yep, so we covered this in Chapter 8, but a quick review of it. An ACL is a control list. It's made up of the access control entries, and it's really just about the authorization levels and how they come about, security identifications. Whether it's a group, whether the computer has accounts on it, or you have to have some kind of account. The authorization levels, it's up to the user group, systems, whether it's denied or not. And that's all we're going to be looking at. So let's take a look at some of those controls. So these are all the ACL controls that we have available to us. So you can delete, which allows someone to delete the object. You can read it, write it, you can modify, execute. Execute allows it to run an executable program. Sometimes that's an important part of their job. If it's on their workstation, they got to run a third-party software. And full control allows all abilities included permissions. No access denies the object from it. So it is bound to an object security such as a file or directory. So some group can log in, or a user logs in. If they're within the group that has only read access, that's all they'll be able to do. If they have access to write or modify, they'll be able to do that, or if they'll have access to execute. So it just is the different levels that they have that allows that system to come and work. So the different areas of access control, the model. Access models are the core that identifies how the user accesses an object. An enterprise determines the best model based on how its organization is structured and the policies within the organization and the benefits that it has. There are several different models, and we're going to look at them all. Discretionary access control, mandatory access control, role-based access control, and attribute access control. So although there's all the models, we covered these a little bit in Chapter 6, we're going to get into them a little bit more. So discretionary access control is the most widely used control method. It is defined by the Trusted Computer System Evaluation criteria. It means restricting access to objects based on the identity of subjects and groups. Controls are discretionary in the sense that the subject with certain access permissions is capable of passing that permission on to the subject. The DAC allows the owner and resources managers who can or cannot access the item. Owners maintain the access ACL and grant or delegate that information. So basically, just as how it's defined, the owner has it. Then we have the mandatory access control. Allows the system administrator to maintain the security aspect of the object, is established by the TCSEC and defined as a means of restricting access to objects based on sensitivity. So the access of this object is based on the sensitivity object versus the subject matter. So this is how, accounting. Only so many people will have access to accounting versus allowing it to a different area. This is one of the most secure methods requires both the object and the subject to have security labels to assign that information. And you have a role-based access control. Role-based access control is also known as non-discretionary access. It grants access to the object based on the subject's role within the system. Three aspects are taken into consideration. The role, assignment. A subject can execute a transaction only if the subject has been selected or been assigned a role. All active users are required to have an active role. Role authority is the subject active role must be authorized for the subject, and transaction authorization. A subject can execute the transaction only if the transaction is authorized by have that. Basically, this is all done access within the RBC system is considered the administrators, because the administrator will provide who has access to do what. The last one we're going to look at is attribute-based access control, policies and functions. The ABAC control based on systems grant for the subject based on additional attributes they must have. For example, when access a system that is available only to residents of a particular town, that subject may have to enter an address within the town. This allows the administrator to have more granularity over what's happening. Some authentication factors we need to look at. We looked at authentication. We looked at authentication at the beginning of the chapter, beginning of the class. And basically, there's three things we're going to look at authenticity. Subject, there's three basic things: something you know, something you have, or something you are. Something you know, you have a login, a password that you have to keep. That combination lets you into that system. Password is generally combined with a unique identifier. So usually it's an email address. Password should have 8 characters. It should be changed frequently, 45 to 90 days. It should include special characters. Shouldn't reuse passwords, use different ones for different accounts. All that stuff that most people don't do. Then you have you'll have like some security words. What city were you born? What high school did you go to? What was your favorite book? These are some things that you have. Weaknesses of this is one challenge is using passwords is memorizing them. If you have too many, it's difficult to memorize. So we want to be careful with that. Something you have. Something you have could be a token. Can help you identify what's going on. An ATM card, a token, a driver's license, passport. This identifies who you are. So this way you can use that to log in, and it gives you that login. So you have two types of tokens that could be used. One's synchronous and one's asynchronous. Uses a counter that you can use, or it responds to the means of authentication. Smart card is the same size as a credit card, and there's a computer chip embedded, and you usually have to have some kind of reader to hook that up, and it allows you to have someone with that smart card along with a password to use that. This type of card is usually with a reader and has that in there. Then you have contactless smart cards. These are often used to access facilities. So you open a door, it has a RFID in it, and it allows that to open. And you also have a time variable token, which is synchronized to the main system, and you have 60 seconds to put in your login password and the token number. And all three of them have to match in order to get in. So that's just something else that they're going to have. That's something that you will have. So let's just take, and then the last thing, something you are, is biometrics, facial patterns, retina, handwriting samples, or something that's repetitive. This we talked about last week also. And then one of the errors, you can have a false rejection or a false exception. And these are some of the things we looked at last week. You can also have physiologic-based biometrics, physiology-based biometrics, which is authentic, such as your fingerprints, behavior-based based biometrics, on how you speak, what's your tone, something on that order. So these are some of the different things that are on there. Some single-factor authentication uses the factor only once, something you are. This type of authentication allows that. Two-factor authentication is one where the user provides two independent authentication methods, whether it's the card and facial recognition and a password or something on that order. So these are some of the things we're going to look at. Challenge response. So here, if you look at this, challenge response is an asynchronous token. Authentication occurs via communication with the token, the authentication server, and user. A request is sent to the authentication server. Random numbers will appear, and it has to be returned. The user has the enter the challenge into the token. The token encrypts it and sends everything over, waiting for it to come in. So this is kind of how it's going to work. You have one, request access up here, then 2, challenge, and the token is sent. 3, enter the token number. You get the token back that it was displayed here, and it goes back to my host, and then it comes back over to here. So you can see it's just a multi-step way of using this information. Kerberos, a network security protocol that provides authentication and authorization services. And we're going to look at the 3 different types of systems: KDC, TGS, and authentication. It's a network security protocol that provides authentication and authorization services on the network. Communication on an unsecured network allows attackers to listen onto the network to steal your credentials. Kerberos uses strong cryptology in order for the client to prove the identity to the server. Once the identity is proven, the communication is encrypted, credentials obtained, and it allows that out. So basically, it prevents plain text from being used, sent over the internet network, centralizes usernames and passwords, making them that, removes vulnerability. Kerberos is based on 3 systems, as we mentioned. The Kerberos Trusted Key Distribution System, the Key Distribution Center, KDC, Ticket Granting Service, and Authentication Service. It provides the ability to have communication in a secure manner over an unsecure network. Also, it's a sign of a single sign-on, which I'll talk more about in a second. It has, the user should be, this should be transparent to the user, should provide security and scalability. So as the business grows, so does that. So it doesn't lock you out. So how does the process work? Client requests information up here, first client, right? The authentication service. And this goes back and says, yes, this person has been created a session for them. Ticket has been sent over, client to the server, and then service communications. So the user enters the password into the client. So up here we enter our password. The client performs a hash or password, creating a secret key. The client sends in clear text message user ID. The authentication server uses 2 messages if the user successfully authenticates: a ticket granting number and a client number. The client receives the 2 messages after decrypting the TGS system, the client uses that. So that's how the system overlooks. What are some weaknesses that might come with that? It's a very secure protocol. However, all protocols have weaknesses. It's important to note that any weakness with Kerberos are based on the concept within the protocol and not underlying cryptology. So, how can someone get in? Brute force attacks. Systems is susceptible to brute force, which just means a lot of people trying to get in. Key storage. All keys must be stored securely for the user and the server. If this is done, the ticket and cached on the system. If an attacker were to obtain access to these tickets, he or she could get in. Clocks must be synchronized to complete authentication. Central server continuation availability. Authentication on the network is occurrence. Requirement for host synchronization and potential single point of failure. So these are some of the issues that could come up with using that system. Next is network access control. Network access control, sometimes called network administration control, is the use of policies within the network infrastructure to limit access to resources until the system proves that it has complied with the policies. Policies are defined by the network administrator and can apply to antivirus software, software version, software updates, and any other aspect. The components involved the NAC, network access control, include computer systems, routers, switchers, servers, firewalls, addresses, address tables, networks, devices. All this is part of the access control. So, do you remember the 7-layer OSI line? Well, we're going to be talking about layer 2 down here and how all that comes together with our control. This is the data link layer. The data link layer allows communication to system within a wide area of network. A WAN. The communication of a system is on the same local area network. Devices are supported through these protocols and associations with the layer 2. The logical link control processes the data flow, and the media access control provides determination as to who can talk with the network. The MAC address is a unique identifier on a network device. Each MAC address is assigned by a vendor of the device and associated with the network interface. Or in a NIC card, a MAC address is 48 bits long and has identifier as a 12 digits, hexadecimal digits. The first 6 identifies the manufacturer, formerly known as IEEE. The last 6 identify the serial number. This is a unique number that is sent throughout the world. You're the only one. Every NIC card has their unique number on it, and it's set by the IEEE. So if you have a wireless card in your laptop and a wired NIC card, they are 2 different NICs. Your phone will have a NIC in it, and that is the only one in the world with that information on it. The MAC address is a unique identifier. When the device is powered up, it is sent out on the network. And that's how it tracks back to where you are. These numbers are controlled by IEEE. So, let's talk about layer 3 techniques. Layer 3 of the OSI models refer to the network layer. It is responsible for transmitting traffic from all sources and networks to its destination in separate networks. Some of the functions provide on the network layer: forwarding and addressing routers. Access control list. When you can configure access control lists on the router to deny certain accesses to the network, and allows that. To determine whether the packet should be forwarded or dropped. So this layer 3 controls any of the packets coming up. Do they belong here or not? And we have the route maps. Route maps are from the administration to direct the flow of traffic. A route map allows the administrator to define the routing protocol policy before the routing table on the router. Creating a route map is called policy-based routing. An administrator sets this if and then a route can be used multiple policies requiring. The ACL can be used to match this router. Disabling IP routing. Certain situations, disabling the IP network may be a necessary step. For instance, if there's a virus, human resources traffic networking, instead of allowing the virus, you can disable the address. So some wireless. IEEE 802.11 has been established for wide area networks. This particular standard, numbered 802.11, was established in 1997. Substantial amendment to allow multiple address. Establishing a standard ensures that all wide area networks can operate on one another with controls of the network. Basically, this allows you to go from your home to work to school, anywhere, and it allows everyone to have the same technology in use. So you have a service set identifier, which identifies the WAN access point. All access points range from that. Identification. Enabling the MAC address table on a wireless identification. Enabling the MAC address on a wireless AP limits the devices that are able to connect directly. For example, the building may hold a single computer on each floor. Each of these companies may have several access points, allowing a company on the 7th floor to ability to gain the company on the 8th floor. Security may be enabled. Confidentiality. Wired equivalent privacy, WEP, was designed to provide encryption between the access point and the client. WEP algorithms is a secret key to protect confidentiality of the information between the two devices attempting to connect. Tools were developed shortly after the release of WEP to break its encryption if the attacker uses such tools and the encryption fails. Communication between the AP and the client service. WEBs use a fixed 40 or 104-bit encryption scheme and a 24-bit initialization vector. As the two components has its secret key, the initialization vector is relatively short, so when the attacker monitors the network, the key is repetition and enables the attacker to figure it out. Authorization. Having access to the WAN may require you to accept certain risks or agreements within that work. Being done on a network will compromise the network and the organization that the network belongs to with banner messages. Single sign-on. This is what most companies are pushing towards. You don't want employees to log on to 5 different applications with 5 different logons. So we're making a single sign-on. One login, one password, eliminates everything else. What do we have to make sure? Basically, we have to link all our applications. So single sign-on is a method of access control that allows users to log into the system and gain access to all their resources within the network with one initial login. So if SSO is not implemented, the user needs to log in multiple times for each application. So you got to have a different one for your email, one for your application you're using, one for your voicemail or whatever. So what's the sum of this? The single sign-on eliminates the need for remember multiple passwords by reducing the number of passwords and logins. Ensures that the same password policy is applied. Yeah, because if you have an application that doesn't have the same policy used, then that's in violation of your standards. Reduces the need for the administration. So basically, overall, SSO reduces the workload for both the login, the users, and the administration. It allows them to have one login that is robust enough and can be defined. So some of the things we should be looking at for a single sign-on. What is the scope of it? How long are we going to use it? It allows them to authenticate once the access multiple systems and applications. Particularly the interface should be independent of the authentication method. The SSO interface provides the capability to use credentials in other systems. Configuring the user's role. Adding access controls previously discussed in this chapter provide an extra layer of security. Using credentials to limit the access to the resources and document essentials and role of this. This tool allows it to have it. Some common features is various ways to implement the SSO within the infrastructure, determining what systems deploy, when, and how. Kerberos we talked about, previously stated, it's a trusted way to have it. We can have cookies on the machine. Once the user logs in, the cookies is placed with his and her machine. And when the user wants access again, it's there. Or smart card and biometrics. These are just some of the different methods. Enterprise SSO allows credentials to be passed outside the corporate domain network, participation of it. So that's all that we have for that. And what are some of the best practices that we have? Let's see. We can. Enterprise organizations that implement best practices control must understand the risk associated with material non-alteration. How important is it to allow customers support, engineering, and information to the system? If the company is open for sharing documents, we have to discover and identify all data on the network. Develop policies based on the risk associated with the data. For example, if an organization maintains credit card and social security information of its customer, the risk is high. To reduce this, we have our systems in place. Place appropriate access control and data based on the risk level. For example, software development files that we might have, continuous monitoring and test policies and access controls to ensure that the loophole is not opened. Continuous testing would be important. So what did we cover? We learned about what understand the significance of information within the enterprise helps the administrator grant proper access to the working area. Limited access reduces the area. We learned how the OSI 7-layer link, how that takes into account, and the different routing that might be have. So that was chapter 10, week 10. So thank you. Remember to smile,